Hello everyone, and welcome to Rationalizing Denominators. In this video we're going to deal with monomials in our denominators. Now many times textbooks and instructors will ask you not to leave roots or radicals in your denominator, so we do what we call rationalize them to get those roots or radicals out of our denominators. The key to this is to make your denominator into a perfect root, either a perfect square or a perfect cube, or whatever, a perfect fourth root, and you do that so that you can simplify that, because the square root of 25 would simplify to be 5. The cube root of 27 would simplify to be 3. So we want to make that denominator into a perfect root. Now, since we're dealing with fractions, remember we want to keep the fraction equivalent. So whatever I multiply my denominator by, I must also multiply my numerator by that same number to keep that fraction equivalent to its original value. Then we can simplify if possible. Okay, so rationalize each one of these denominators. The first problem we have is the square root of 2 over the square root of 7. Now I can't simplify. I could put that underneath one radical, but I can't simplify the fraction 2 over 7, so that would not help. I want to get rid of the radical out of my denominator. So to make the square root of 7 into a perfect root, then I'm just going to multiply it by itself. And that will make that into a perfect square, because the square root of 7 times the square root of 7 is the square root of 49. However, like I said at the beginning, whatever we multiply the bottom by, we must multiply the top by. So now I need to multiply my numerator by the square root of 7. Now, since they're both under the square root symbol, I will go ahead and multiply those two numbers and leave them underneath that symbol. So that gives me the square root of 14. I can't simplify the square root of 14 because it's not a perfect square, and we don't have a perfect square that will go into it. However, the square root of 49 is a perfect square, which was the whole reason we went through the process, and that just comes out to be 7. Now again, I cannot simplify this fraction here because the square 14 is under the square root symbol, whereas 7 is not. So this will be my final answer. Okay, how about the square root of 1 over the square root of 5? I cannot simplify 1 over 5, so let's separate that and make that, put a square root over each one of those numbers. Now the square root of 1 can be simplified because it's a perfect square, and that just becomes 1. However, I don't want to leave that square root in my denominator. So I'm going to make that into a perfect square. I'm going to multiply it times itself, which would make that the square root of 25. Again, whatever I multiply the bottom by, I must multiply the top by that same number to keep the fraction equivalent. So 1 times the square root of 5 is simply the square root of 5. Square root of 5 times the square root of 5 is simply 5, or the square root of 25, which can be simplified Now, again, I cannot simplify those 5s because the 5 in the numerator is under the square root symbol, whereas the 5 in the denominator is not. So that would be my final answer. So again, remember our objective in this lesson is to remove the radical from the denominator by making our denominator into a perfect root. Okay, so in this next problem, we have 4 over the cube root of 3. So now I need to make my denominator into a perfect cube. So think about your perfect cubes. 1 cube is 1. 2 to the third power, 2 times 2 times 2 is 8. 3 to the third power is 27. 4 to the third power is 64, and you could keep going. So my objective is to use multiplication to make the cube root of 3 into one of these perfect cubes, 1, 8, 27, or 64. So which one of those numbers is a multiple of 3? Well, 27 is. So I could multiply the cube root of 3 times the cube root of 9 to make that into a perfect cube. So I can make that into the cube root of 27. However, again, whatever you multiply your denominator by, you must also multiply your numerator by the exact same thing. Now, the 4 is not under the radical, so that will stay outside of the radical. It will become 4 times the cube root of 27, or 9, sorry. So now the cube root of 27, that's a perfect cube. That's just 3 in my denominator. I cannot simplify the cube root of 9, so it's going to stay like it is in my numerator. Now, you also need to check to see if you can simplify the regular numbers in your fraction, the 4 and the 3, which cannot be simplified, so I would leave my answer just like this. All right, the last problem we have here is the square root of 2x over 5y. Again, I cannot simplify the fraction in the form that it's in, so I'm going to rewrite it, separating my numerator and denominator. I want to make my denominator into a perfect square. So anytime I want to make a number into a perfect square, I can just multiply it times itself. Okay, so now that becomes, since the 2x and the 5y were both underneath the square root, I can multiply that out to get 10, the square root of 10xy. In my denominator, 5 times 5 is 25, y times y is y squared, which is a perfect square. 10xy, it's not a perfect square. No perfect square will go into 10, so I'm going to leave that just like it is. 25y squared is a perfect square. That's the whole reason we went through this process. Becomes 5y. And again, I cannot simplify those numbers or variables because my numerator is under the radical, whereas my denominator is not. Okay, hope you found this video to be helpful. Thank you.